This chapter deals with chemical reactions, and there are lots and lots and lots and lots of different chemical reactions out there, but the majority of them fit into these 5 categories. Not all of them, but the majority. And what are those 5 categories of chemical reactions? Here they are. Hopefully you can see this. Number 1, combination. Number 2, decomposition. Number 3, single replacement, or sometimes it's called displacement. Number 4, double replacement, and it's also called exchange. And then number 5, combustion. Okay, so let's talk about some examples and how are you supposed to identify what type of chemical reaction it is. Well, a combination reaction, you know that it's combination when you have one product. You can have 2 or more reactants and then one product. So on the right of the arrow, it's always just one product. An example of this would be if you've got magnesium reacting with oxygen gas, it's going to produce magnesium oxide. We remember that we have to balance chemical equations. We can't mess with the subscripts. We put coefficients. So if you put a 2 here and a 2 here, this is a balanced chemical equation. This is an example of a combination reaction because you have 2 reactants, but you have to have only one product. That's the key, just one product, okay? Now, what is a decomposition? A decomposition reaction is you have just one reactant, so only one substance to the left of the arrow. An example of this would be something we would do in lab. Potassium, I'm going to do potassium chlorate, not potassium iodate. So potassium chlorate, KClO3, you remember your nomenclature, will decompose. If you heat it up, the word decompose just usually means you're going to heat it up and it's going to break down. And it's going to form potassium chloride plus oxygen gas. If I balance the equation, I'll put a 2 here, I'll put a 3 here, put a 2 here. But what's the important part? How do I recognize that this is decomposition? One reactant, okay? Combination, one product. So you could have anything, but so long as you have one reactant, it's called decomposition. One product, it's called combination. Now let's get into the more interesting ones. Single replacement and displacement. I'm going to erase over here these 2 guys, and I'm going to give you guys an example of single replacement or displacement. Let's say you've got magnesium, and you throw that magnesium into some hydrochloric acid. There's something called an activity series. Anything higher on the activity series can kick anything lower on the activity series out of its compound. You will see the activity series in your lab manual. All right, I don't think Stoker has it in the textbook, but I know it's in the lab manual. So if you look at the activity series, you're going to see that magnesium is higher than hydrogen on the activity series. So that means the magnesium can kick the hydrogen out. And if it can do that, then the hydrogen goes off as H2 gas. Remember, hydrogen is always, if it's by itself, it has to be a diatomic molecule. It can't just be an H by itself. And then the magnesium is going to hook up with the chloride. Well, chloride is -1, magnesium is +2, so you have MgCl2. So you need to balance the equation. There you go. That's an example of a displacement or a single replacement reaction where something that is higher on the activity series will kick something that is lower on the activity series. And you can see how to recognize it. Let's do another one. Let's say I had aluminum and copper chloride. So this is copper 2 chloride and this is aluminum. if you look at the activity series, aluminum is higher than copper. So what's going to happen? The aluminum is going to kick the copper out. So copper just becomes copper solid. You'll see it precipitating out. And then the aluminum hooks up with the chloride. Well, aluminum is +3, chloride is -1. So your aluminum chloride is AlCl3. So now we need to balance this equation. I'm going to go ahead and put a 2 here and a 3 here. Or sorry, forget I did that, guys. I meant the exact opposite. So I'm trying to get the lowest common multiple. A 3 here and a 2 here. That balances the chlorines out. Now I have 6 and 6. When I did that, I now have 3 times 2, 6 chlorines, 2 times 3, 6 chlorines, but now I've got 3 coppers, so I better put a 3 here. Now I have 2 aluminums, I better put a 2 here. So now it's balanced. How do I know it's a single replacement or a displacement reaction? I have this kicking the copper out and taking its place. So now instead of the copper being hooked up with the chlorine, the aluminum is now hooked up with the chlorine. That's your single replacement or displacement reactions. And we usually have to look at the activity series in order to know who's higher and who's lower on the activity series. The last one, not the last one, sorry, the next to last one is double replacement. Double replacement, I think of it as, you know, square dancing, do-si-do and change your partners. That's what double replacement is. Everybody changes partners. So when we look at a generic double replacement or exchange, AB plus CD. Okay, think of this as the cation, because always the cation is first, and this is the anion. And this is also a cation, and this is the anion. So what happens in an exchange or a double replacement is that they literally change partners. So this cation hooks up with this anion, and this cation hooks up with this anion. So your products are going to be AD plus, normally it's all on one line, but I don't have any room, CB. Why am I putting the C before the B? Because we always, in ionic compounds, put the cation before the anion, okay? So let's say I have some real things. Let's say I've got sodium chloride plus silver nitrate. Now this is the test that we use in lab to identify the chloride ion, because when silver and chloride hook up, according to the solubility rules, that becomes insoluble, and then you get this cloudy precipitate in the solution. So that precipitates out. All right, so think of it just like I told you guys. Think that this is A, and this is B, this is C, and this is D. The nitrate is a polyatomic ion. By definition, polyatomic ions act as a unit. You're not separating it out at all right? So what products are we going to have? We have to write correct formulas. You're not allowed to write a formula that makes no sense. So sodium's +1, nitrate is -1, so that would be correct. NaNO3. And then this silver is +1, chloride is -1. Oh, so I gave you a nice little easy one, AgCl. Okay? This is insoluble, and that's what you actually see when you put those two things together. All right, let me give you guys another one. Okay? Let's try one more for this double replacement or exchange. But I'm going to make it so that you're going to have to create a compound that isn't just a quickie thing like this. You'll see what I'm talking about. Let's say I've got calcium chloride plus, let's say, potassium sulfate. Okay, I wrote correct formulas. Calcium's +2, chloride is -1, and I have 2 of them. So that chapter with all of the ionic compounds that we covered. I think it was like chapter 4. It's here to haunt you forever. You really need to know this stuff, especially now in this portion. So we have calcium chloride and potassium sulfate. Sulfate is -2, potassium's +1. Okay, so what are the products? Remember, this is A, this is B, this is C, this is D. Let's create our products. The calcium is going to hook up with the sulfate. Now, calcium is +2, sulfate is -2, so that one is just going to be CaSO4. Okay. Potassium is going to hook up with the chloride. The potassium's +1, chloride is -1, so that will be KCl. What you don't want to do is take these 2's down here. This is just saying you have 2 potassiums for every 1 sulfate. But when you've got a potassium that's +1 and a chloride that's -1, why would you have a 2 and a 2? You lowest multiple. But what you will do is put a 2 here. So what we have over here is another double replacement, okay? And then the last of these types of chemical reactions is combustion, which is down here. Let me erase this. Combustion means you're going to burn something in oxygen, and usually it's going to be some type of an organic compound. So we saw this in an earlier chapter, C3H8. This happens to be propane. If you guys are doing any barbecuing and you're using any propane gas, C3H8 with oxygen. The products will always be, assuming you have enough oxygen, always be carbon dioxide and water. So combustion reactions, you're always going to end up with the carbon dioxide and water, assuming you have some type of hydrocarbon, some type of carbon-containing molecule that has carbons and hydrogens. If you balance the equation, this is something looks familiar. We did it a while ago. And you put a 5 here. There's your balanced equation. But the whole point of this is to show you an example of a combustion. Okay. Good. We're all set with the types of chemical reactions. Practice, please.